presenter for today's presentation. I'm also joined by Kiran Kumar, who's a Senior Product Manager at Webroot and will be today's co-presenter. Before we get started, just a couple of quick housekeeping items. All attendees have been muted. If you have questions about the presentation, please enter them in the question box in your console. We'll read and answer the questions immediately following the presentation. Again, thanks for your interest in learning about streaming malware detection, and let's jump right in. So first, quick agenda on the things we'd like to cover. We'll go through some of the business challenges, especially as they pertain to malicious files and ransomware, as well as today's polymorphic malware and polymorphic variants. Then we'll introduce streaming malware detection. We'll define it, and then also dive a little deeper into partner and customer benefits. We have an animated demo that we'd like to share with you to kind of reinforce some of the things that we're presenting. And finally, we'll do a deeper dive on the underlying machine learning technology that powers the solution. So first, some of the business challenges, and these are great malware stats that were derived from Webroot's proprietary research and pulled from our BrightCloud threat intelligence platform. So first, 85% of malware infections are occurring due to web browsing. So this points to the fact that basic internet use is a high-risk activity for all organizations, regardless of the size or the sector that they're in. It also reinforces the importance of stopping malware at the network perimeter before it can penetrate into an organization's network. The number of individual malware and PUA, which is potentially unwanted applications, PUA variants has increased 15% a year for the past few years. What's interesting is that even though the variants are increasing, the malware frequency has remained steady over this time. Some other interesting facts are that we're seeing that malware and PUA files are more unique than ever. From October, we have data from October of 16 through March of 17, for instance, that shows more than 95% of new malware and PUA variants are only observed on a single PC. It really points to the polymorphic nature and the fleeting or ever-changing nature of malware today. And only about 0.5% of new malware and PUA files were seen on more than 10 PCs. So again, this points to the polymorphic nature. Finally, 60+% of companies have been affected by ransomware. This is a very, very high number. Within that 60%, financial services and retail have been the hardest hit. So a little bit deeper dive on polymorphic malware. So polymorphic executable is able to constantly change and mutate itself without affecting the underlying algorithm. And it does this to obfuscate itself from detection. So polymorphic variants are constantly changing. They morph when they enter the organization. These variants are extremely short-lived, and the impact is that they're rendering signature-based antivirus and endpoint security ineffective. So we need new solutions for today's ever-changing threats. This chart shows a malware distribution by file type. So it's a sample set that we pulled from VirusTotal. It represents data from May of 2016 to April of 2017. And it's a sample of over 3.5 million malicious files. And what you see is that PEs, which is a Windows file type called portable executable files, are over 65% in terms of malware distribution. So PEs have been primarily responsible for distributing malware. After that, you'll see Android, text, archives, XML files, different file types. But the predominant file type is these portable executables, and that's what we're focused on with the first generation of streaming malware detection. So there are a number of existing malicious file detection technologies in use today, and what we're seeing based on our data and what we're hearing anecdotally from our customers, is that they're insufficient for stopping today's malicious files. Files are still getting in, they're still wreaking havoc and disrupting business for organizations of all sizes. So sandboxing is a traditional method of file detection. It tends to be complex and expensive, and because sandboxing takes some time to explode and execute the file and evaluate it, there tends to be queuing for the sandbox, which introduces delivery latency for files to the end user. Another type of file detection technology is signature or heuristics-based protection. Some examples of this are IDS, IPS, UTM. Various devices are using signature-based malware detection technologies. We've seen that this is very reactive technology. Signatures are developed after the fact, once the malware is evaluated, and many organizations today are augmenting these technologies with additional technologies to strengthen their defenses. So let's dive into streaming malware detection, our brand new Webroot BrightCloud solution. We just announced general availability of the solution last week, Tuesday, July 11th. So the intro slide here, the new machine learning-based detection technology is able to detect malware more quickly at the network perimeter. We're able to detect files in transit as they're in motion and streaming through a network device. This technology is especially appropriate for all malware, but especially for zero-day and polymorphic threats. And we use the headline and we use the newspaper font because we believe this is innovative, revolutionary technology, and we're the only cybersecurity provider who offer a streaming malware detection solution that's based on machine learning. It works extremely quickly, and for our partners, the benefits are incremental functionality. We're able to provide incremental functionality to our partners if they don't have malware detection technology in their device, or if they do, we're able to augment that, increase the efficacy. We play very well with other solutions. We can sit in front of a signature or heuristics-based solution. And we also believe that this can provide an incremental revenue opportunity for our partners as well. So in terms of BrightCloud streaming malware detection, what we're saying is that this empowers network edge devices to effectively combat the challenges of both traditional and today's cutting edge malware. So we developed the offering specifically thinking about the challenges of polymorphic malware, polymorphic variants, zero-day threats that have never before seen files. We're able to detect these in transit, in real time at the network perimeter. This is an extremely fast and accurate technology based on machine learning. It requires less resources, fewer resources than other solutions. And part of that is because we're able to scan the file byte by byte as it streams through a network perimeter device. So we can make very rapid onboard determinations as files stream through these devices. And that's because we take the result of massive machine learning training models and we actually put them on board on the device to make local file determinations. And that helps speed, it helps increase both the speed and the accuracy of the process. So in terms of machine learning based malware detection, we talked a little bit about that this is on-board machine learning detection. We're able to analyze packets of every file as they stream through a network device. And we do this by byte parsing of the file. So this is extremely fast technology. It does not introduce network latency. We're able to analyze and make determinations on packets very quickly as the files are downloaded. The net result is that this frees up network bandwidth. So organizations that we work with have made large investments in sandboxing technology, endpoint technology, other methods of detecting files. And what this does by freeing up network bandwidth and dropping a large percentage of the files at the perimeter, it makes the other technologies work more efficiently and more effectively, thus increasing the return on investment in these technologies. It also removes the need to reinspect files that streaming malware detection determined to be good. Just another word on performance. So because we're parsing the file as it streams through the device, just a quick comparison, we're able to classify over 5,700 files per minute compared to a traditional sandbox, which is able to analyze or run 11 files per minute. We've also done in-house comparisons versus other traditional malware engines, and we find that we're over 30 times faster than traditional malware engines. So the zero-day detection, the speed, the accuracy are all tremendous benefits. We work with existing technologies, so we don't replace technologies, but we're an incremental layer of defense. So we work well with sandbox, with existing endpoint protection, both signature-based and heuristics-based. So we would consider this technology an incremental first layer of defense right at the network perimeter that offloads the burden from other traditional file security detection techniques. The integration points for streaming malware detection, again, are right at the network perimeter. So what we're saying is that our partners can add this technology to their existing devices via a very simple to integrate pre-compiled SDK. And the technology is appropriate for things like network firewalls, intrusion detection and prevention systems, and web gateways. It's also appropriate for unified threat management devices, web proxies, sandboxes, and lastly, online file share and sync solutions. So there's a number of places that this technology can augment the existing capabilities of a device to add this very rapid file detection and blocking technology.
Yeah, that's a great point, Ken, on the previous slide. You know, we're not another point solution or a device that you need to deploy. Very easily integratable within existing technologies that are out there. And that was kind of our goal and vision when we embarked on building such a, the solution so that it's easily integrated within existing network security devices. So.
Yeah, that's a great point, Karan. This is technology that was developed strictly for our technology partners. Webroot in no way competes with our partners. We provide technologies that are integral ingredients or key ingredients to our partners' success. So this slide actually highlights some of the partner benefits that we see with this technology, right? So first, we're adding this advanced machine learning technology to devices to either give our partners' devices an incremental benefit, a feature, a capability that they didn't previously have, or to augment a capability. If they're already using some type of signature-based network AV, we can either replace that or we can sit side by side with it, maybe in front of it, to increase the effectiveness. This solution is effective for all types of malware that exists today, but we especially were considering zero-day, never-before-seen threats and polymorphic variants when we developed this solution. And the machine learning technology that Karan will get into in a moment, will help illuminate that. But when we train these massive models in the cloud, and we're using massive instances at Amazon Web Services and also with the San Diego Supercomputing Center at the University of California at San Diego, we're then able to take the results of these massive models that are using enormous cloud-based infrastructures. We're able to boil that down into a production model that we then download to the device on a daily basis. So this technology, because it's making onboard determinations, is 30 to 40 times faster than signature-based solutions. The machine learning enables us to have continuous improvement and self-learning. As we see more file samples, as we're in the market longer, as we train up the model, we continue to increase efficacy over time and effectiveness. So this self-improvement is extremely important to us as we build and deploy the solution with our partners. We mentioned previously very easy integration with a precompiled SDK. We encourage all of our partners to trial and try out the solution for themselves, both on the ease of integration and on the performance and efficacy. We believe that this will provide an incremental revenue opportunity and that it requires fewer resources than other existing solutions in the market today. Now, we know that our partners are trying to differentiate themselves with their end customers, right? We know that our partners want their products to perform in POCs, that they want to differentiate themselves from their competition, and that they're thinking about the problems that their end customers face. Well, we hear, and our research backs it up, that files are still getting through. Malicious files are still penetrating network defenses. They're still wreaking havoc within organizations. And we believe that streaming malware detection provides this additional layer of security at the network perimeter. It doesn't replace anything for our partners' customers, but it provides an incremental layer of defense. It also works upstream from existing technologies such as sandboxing and endpoint protection products. So it increases the investment, increases the ROI in those products and makes them work more efficiently and effectively. The solution, I can't overemphasize that it's extremely fast. It's able to make determinations in real time, in milliseconds, as the file is streaming through a network perimeter device. And it also reduces the latency of file delivery. So within our partners' target customer organizations, employees receive files faster because we're reducing latency. So a number of benefits for the end user, end customer. Now we'd like to show you an animated demo that we built, which will hopefully build on some of the things that we've been presenting so far. So let's move into the demo and start that. And Karan, would you like to dig into some more detail on what's being shown here in the demo?
Yeah. So this slide or video is really intended to illustrate, when SMD is integrated within the network device, as I mentioned, how it's able to detect or make determinations very quickly and then be able to route it, based on thresholds or policies that you can set, based on the type of prevention that you would like. So as you can see in this video, right, so SMD that's within this network device is making determinations as sections of these PE files are passed through the device. And then based on that, you're routing it, you're detonating it, or you're routing it back into your network or into the sandbox, right? So, and that's a key point, right? So where SMD is not able to make that determination, you can then send it to your sandbox for additional verification. But in instances where we don't make a recommendation, we also provide a confidence score on the determination, right? So what is the confidence score? Based on that, that threshold you can set on how you want to route it. So in essence, right, so this solution can greatly minimize the queuing of the sandbox. So we know that sandbox, while fantastic technologies, it's expensive and adds slowness, right, because of the reverse analysis that it needs to do. So definitely, so SMD can act as either a primary layer, right, where you're using that as the primary defense mechanism, or be a pre-filter to provide detection and prevention before it gets into your network. So taking that weight off of sandbox or other similar technologies to do that further analysis, right? So greatly reduce the queuing of it. So So I like to use a metaphor, when describing this technology is that what comes close is, standing in airport security lines, right? So today, we stand in line and then wait for the scanner, and then you raise your hand and, go through it, right? So that backs up the queue, right? So with this model, right, the idea is, right, you're just walking through, right? And then based on, that fast detection that Ken highlighted, right, the speed is absolutely critical. We're able to, quickly make that determination and then flag that person, right, of any metal detection or whatever that they may be carrying. So that's a metaphor I like to use, that, as the file is passing by, where we extract it and then make the determination. So that really avoids any additional latency or anything like that. So this is a video to illustrate that, and hopefully you get a sense of how this works. So let's take a look at, what's underneath this, right? And how does all these things come together? So machine learning has been a core principle and a foundation technology for anything that we've done at Webroot, right? We are one of the leaders and pioneer in developing and using advanced machine learning to detect threats in real time, because the security landscape has changed dramatically over the last decade, right? It's no more protecting the corporate network. It's your home, it's your hotel, right? Or it's your airport, etc. So it's important that the threats are caught in real time as it's occurring. So it's no more a matter of days. It's about hours where threats can attack you, as Ken highlighted, especially with polymorphic malware. So when we embarked on building this solution, which was needed to do inline processing, right? So we actually used very sophisticated machine learning technology and advancements that we've done over the last 10 years on it, and a lot of proprietary algorithms, right? Because it previously, when we had the full file and making determinations on that we had extreme expertise on that. But this is now, as it's coming in, we're able to make that determination. So in terms of integration, right? So SMD is an on-prem device, right? On-prem solution that's delivered via easy to integrate pre-compiled SDK, so within any network device. And the core components of that are the parser and the classifier. So parser is, if you will, that's the part that's responsible for extracting those features as the file is coming through. And classifier is the brain behind this, right? So based on those features that were extracted, the classifier is able to make that determination. So with machine learning principles, right? So in order for the classifier to continue to be smart and intelligent, it's important that the training model that powers those classifiers, right, are retrained on a daily basis. And not only is it trained on what we have seen, right? It's also is able to leverage what we call as active feedback loop with files that we have not seen, but it comes through the device, right, as it's deployed into our organization, and that device may see a number of new files, right, that has never been seen before. So we use that active feedback loop where we leverage that back into the training model so that our detection and accuracy rate can go up, right? Obviously, this requires the full file to be sent through. So that's a very configurable option that we have provided to our customers. So you can turn that on or off. So we have a flag, and based on your preference, you can maintain that. So definitely. With the sections of the files that I mentioned, right? So that's the dimensionality of the features that we can extract. And with machine learning, there's no limit to what number of variables we want to use. So in the next slide, you will see a sample of these what I call attributes or characteristics of a PE file, right? So file size, file entropy, packer type, language code, etc. So these are all features. And what's important here is that not all of these attributes are created equal, right? So what we need to, this is where our proprietary, our IP comes into play, is giving weightage to this, right? So because based on certain attributes or the patterns of the file, right, you need to assign weightage so that you can then use that to make the true determination. And that's where we believe, you know, our solution can provide better efficacy and at a minimum false positive rates, right? So that's very critical. So that's why we've gone through excessive research and practice around, you know, what is that right set of factors, right, or weightage that we can use to on these attributes, because not all these dimensions are created equal. So there needs to be a weightage given to certain number of them. So in conclusion, right, next slide, please. So in conclusion, our key differentiators, right, around streaming malware detection when we embarked on this project is, you know, speed, right? There should be no compromise in terms of speed, right? What I mean by that is no additional latency needs to be added. We know that, you know, within networks, it's important that the speed or the performance of it is maintained, right? So, and our parsing technology that we have built, that's what gives it that ability to, you know, parse through sections of files as it's coming through and making that determination. So just as an example, we ran within our test environments with multi-threaded setups. We were able to parse through and make a determination successfully on, you know, approximately 1 million files in under 300 milliseconds, right? So which can be translated into, you know, almost 500 times faster than a typical, you know, sandbox or similar technology. And the other biggest thing is, right, once we have the speed, is around malware prevention, right? It's all about zero-day threats, right? And interestingly, what we are seeing is it's not just days anymore, it's about hours. So when we ran a comparison, you know, over the last year or so with VirusTotal using benchmarks from several other vendors there, right, we saw was, you know, we were able to make advanced determination and, you know, prior to 15-20 days before any other vendors were able to make a determination on the file. So zero-day threat detection and malware prevention is absolutely critical, and that's what this solution brings to market with this technology. So like Ken alluded to, we are super excited about this technology and what it can bring to our partners, and then you know, translate that into for our end customers, right? So really excited about this technology, and you know, please reach out to us or contact OEM sales if you have any questions or you would like to set up a POC or eval. So Ken, I will hand it back to you.
Great, thanks, Karan. Great information. So now we'd like to take some questions. We have a few. The first one is, what is the recommended time interval for downloading the new machine learning production models to the device itself? Karan, would you like to take this one? Okay. The default is once per day. The models are downloaded once per day, but because we're constantly training new models and building new models, and we have a team focused on that, doing that on a daily basis, customer partners can actually choose to download the model up to 3 times per day. So the next question is this a replacement for network antivirus? Sharon, would you like to take this one?
Yeah, so great question, and an expected question. So the way we would like to recommend is, put this in front, right, of your existing AV, and then measure, over a course of period to see how, it's working out for you in terms of the noise that it's building, or, the detection capability, right? And then use this as a pre-filter initially, and then, eventually based on, performance of it, etc., then we recommend, using this as a replacement technology as well. So.
Great. Another question, is this streaming malware detection or perimeter-based, file detection technology based on machine learning unique in the market today?
Yeah, absolutely. I definitely believe, it's unique for a couple of reasons. So A, it is, we're doing in transit, right? It's not static file analysis where we have the full components of the file. It is in transit within a network device, right? That's one reason. And then B is, completely driven by our, on-prem machine learning based technology. It's not signature. We've not loaded up a bunch of signatures or making cloud calls to it. Similar to our Webroot Secure Anywhere endpoint as well, right? This is it's not signature driven, so it's making determination in real time as the files are coming in. So I do believe this is very unique and the only technology that's available in the market.
Okay, great. Another question that came in is we talked about both the speed and the efficacy of the solution. So this was just GA'd on July 11th, but we mentioned the notion of continuous learning. So can you elaborate a little bit more on the continuous learning process, and how does this solution and the machine learning behind it improve over time?
Yeah, so the continuous learning or active feedback that I like to call, right, is obviously, the training model that I mentioned about is trained based on, samples that we have seen across our endpoints, what our customers see, as well as, other sources. But once this technology is deployed, right, so there's various amount of files that are passing through on a daily basis. So what we're doing is, if that config option is set, right, we can then feed that back into our training model. So that way we're able to, get new sample set in terms of understanding their behavior patterns, etc., and then which will lead to, stronger detection and accuracy. And what I want to say here is, these files that are that pass through the device, it's unique to that organization. We don't share that with others, right? So it's translated as, as part of the training model, which everybody benefits, but we don't, disclose or show to share with others or anything on that sort. So that privacy is maintained.
Great. Next question is around how often our machine learning model is retrained, or how often is it updated?
Yeah, so the classifier is as good as it's the training model that's powering behind it, right? So we publish today minimum of 3 times new training models, but what we recommend to our partners is to update on a daily basis, once a day at least.
Okay. Yeah, and to that I would add, that our model is trained on a daily basis, and we're doing multiple things, right? We're using Webroot's extensive sensor network to evaluate files, and we're also looking at traffic that's passed through both our devices and through real-world devices deployed in the field. and we have a team of we have the machine learning team, data scientists, and we also have threat researchers who monitor that model, evaluate it, and they're constantly training and improving the model. In general, how long does it take to train a model?
That's we believe we've mastered that. It takes anywhere from minutes to a few hours. So that's why we're able to publish this very frequently. It all depends on the type of samples or unknown sample sets that we get, right? And then how we're able to adjust the training model. It's not about training model is not intended to be where we capture every sample set. Then what you're doing is skewing the behavior of the file, right? That way it's very skewed to, oh, this is what I know or what I don't know, and then you basically give the determinant. But instead, this is capturing a sample of certain attributes or behaviors and then incorporating that into the training model so that when an unknown file is encountered, we're able to make that determination based on our learning of it. So so it's we publish multiple times a day, and could be done, and the model takes we built that up and can do that in a matter of minutes or sometimes a few hours as well.
Okay, great. Thanks, Karan. So that's all that I'm seeing in terms of questions. So with that, I'd like to say that, again, thank the participants. Thank you for your interest in streaming malware detection. In the next few days, you'll receive an email with a link to the webinar recording and additional information about the offering. If you have any additional questions, please contact your Webroot account executive. They'd be glad to help you or get a sales engineer involved if you'd like to move forward and take a look at the solution and move forward with a trial. We greatly appreciate your interest in joining today and your interest in streaming malware detection. And again, thank you very much for attending. Have a great day.